So last time we discussed about reaction mechanism, and we also discussed about how to determine reaction mechanism. Okay, and there are two methods for determining the mechanism of reaction, and these are steady state rate determining step approximation method and steady state approximation method. So these are the two methods. So we also discussed about rate determining step approximation method. We discussed an example also. Then we talked about steady state approximation method. We also discussed some examples. Okay, okay. Then we solved one problem. Like this. So this type of problems are asked in questions, in examinations. Okay, and I gave you two problems. Based on steady state approximation method. Okay, perhaps you have tried. Okay, now let us discuss another problem. Okay, let me write the problem first. The reaction to N2O5 4NO2 plus O2 has the mechanism so N2O5 K1 NO2 plus NO3. Second step, NO2 NO3 K2 rate constant, NO2 O2. Third step, NO3 K3 2NO2. Okay, 2NO2. Fourth step, NO2 NO3 K4 N2O5. So this is the mechanism. Okay, and show that the rate law is R equal to K N2O5. Okay, so this is the problem. Okay, now you see how we solve the problem. First, what we do, from the reaction we write the expression for rate according to definition. Okay, so according to definition, what is the rate of reaction? Rate of reaction equal to minus half dN2O5 by dt equal to 1 by 4 NO2 1 by 4 dNO2 dt equal to dO2 dt. Okay, so according to definition, this is reactant minus half this, then 1/4 d this. So this is the rate of the reaction. Okay, now from mechanism, so if I accept this as the rate of reaction, if I accept this as the rate of reaction, let me accept this as the rate of reaction. So from mechanism, rate of reaction dO2 by dt, rate of reaction dO2 by dt, and that will be equal to, so O2 is here only in step 2, O2 is here only, okay, step 2. So this will be equal to K2, this is product, so positive, K2 NO2 NO3. Okay, so this is say 1, this is 1. Now here you see NO2 NO3, NO2 NO3, these are neither reactants nor products. Oh, sorry, NO2 is product, NO2 is product, okay, but NO3 is neither reactant nor product. I repeat, NO2 is product, okay, NO2 is product, but NO3 is neither reactant nor product. That means here NO3 is the intermediate, okay, because this is neither reactant nor product, so NO3 is intermediate. Okay, so now we have to write dNO3 dt, that means d intermediate dt. Okay, from mechanism we will write d intermediate dt. Okay, d intermediate dt. Now from step 1, this will be K1 N2O5 from step 1. Okay, now NO3 is associated with step 1, step 2, step 3, step 4. All the 4 steps, NO3 is associated with all the 4 steps. Okay, but in step 1 this is product, in step 2, step 3, step 4, NO3 is the reactant. Reactant means the term will be negative, product means the term will be positive. Okay, so what I do, next I write step 2. From step 2 what I get, K2 NO2 NO3. Okay, because now NO3 is reactant, so it is minus. Then step this is step 2, this is step 2, then step 3, this will be NO3, step 3. Then step 4, okay, minus K4 NO2 NO3, okay, NO3. Okay, now we know according to steady state approximation dNO3 dt equal to 0. Okay, steady state approximation. So dNO3 dt equal to 0. dNO3 dt, that is d intermediate dt is 0. Okay, so this is a 2, number 2, okay, number 2. So from 2 what we get, I can write this K1N2O5 equal to K2NO2 NO3 K3NO3 plus K4NO2 NO3. Okay, then what we do, we take NO3 common. Okay, we take NO3 common because here we have NO3, so we have to find out an expression for NO3. Okay, so we take NO3 common, so that we have K2NO2 K3NO, then we have K4NO2 NO2. Okay, so then what is the value of NO3? Value of NO3 equal to this divided by this. Okay, so concentration of NO3, and that is equal to K1N2O5 divided by K2NO2 plus K3NO plus K4NO2. Okay, so this is a number 3. Okay, this is number 3. Now here again you see this is intermediate. Here this is product, but this is intermediate. NO is intermediate in case of this reaction. In case of this reaction, NO is neither reactant nor product. In case of this reaction, okay, in case of this reaction, NO is neither reactant nor product, so NO is also intermediate. So what we do, we again write the intermediate dt. Now from mechanism, you see NO is there in step 2. And this is product. NO is there in step 3, and this is reactant. Okay, so NO is involved in 2 reactions. So for dNO dt we will have 2 terms. What are those 2 terms? One is K2NO2 NO3, then this is here in this reaction NO is formed, but in this reaction NO is decomposed. Okay, NO is the reactant, so it will be minus K3 NO NO3. Once again, steady state approximation. So this is equal to 0. Okay. So what we get? Or we get K2NO2 NO3 equal to K3 NO3. So we can cancel these two, NO3 we can cancel. So what we get? We have to find out an expression for NO. So what is NO? This is equal to K2 by K3 NO2. Okay, so here we have NO, so we are getting expression for N. Hence from 3, okay, 3 NO3 equal to K1 N2O5 K2 NO2 plus K3 NO. What is NO? K2 by K3 NO2 then K4 NO2 and this is equal to K1 N2O5 so K3 cancels, so 2 K2 NO2 plus K4 NO2 okay, K4 NO2 and this is equal to K1 by 2K2 plus K4 N2O5 by NO2 so we are getting the value of NO3. Hence rate of reaction equal to for NO3 we can write this value for NO3, okay, so from 1 R equal to K2 NO2 into NO3. What is the value of NO3? K1 2K2 plus K4 into N2O5 by NO2. Now NO2 cancels. So what we get? We get K1 K2 by 2K2 plus K4 N2O5 and this is constant, so we can write K N2O5. Okay, so we have solved. Okay, so we can solve like this. So this is the way how you can solve problems based on steady state approximation. Okay, now let us discuss about chain reaction. Okay, chain reaction. Let us discuss about chain reaction. First, let me give you an example. Okay, then we will discuss about chain reaction. Okay, let me discuss about an example. Say this is the reaction. Say hydrogen reacts with bromine to form 2HBr. Okay, now this reaction may be thermochemical thermochemical. Thermochemical means at temperature 500 to 1500 Kelvin, or photochemical. Photochemical. That means if you heat the mixture, if you heat this mixture at around this temperature, this reaction will take place. This is one way, thermochemical. Okay, thermochemical means by heating. You heat the mixture within this temperature, reaction will take place. Or photochemical. Photochemical means if you allow light, so light means H nu. If you allow light to fall on this mixture, then the reaction will take place. So this reaction may be thermochemical or photochemical. Okay. Now this reaction, suppose I am considering photochemical reaction. Suppose I am considering photochemical reaction. Now how this reaction takes place? How this reaction takes place? That means what is the mechanism of the reaction? What is the mechanism of the reaction? What is the mechanism? So first step is that bromine. Bromine. Let me write it like this: Br2, say H nu. Then what we get? We get bromine. Okay. Bromine free radical. Bromine free radical. This is homogeneous cleavage. Homogeneous cleavage. We get bromine free radical. Okay. Say when we take hydrogen gas and bromine gas, there will be crores of hydrogen molecules and crores of bromine molecules. Okay. মই যেতিয়া হাইড্ৰোজেন গেছ আৰু ব্ৰোমিন গেছ ল'ম, তেতিয়া তাত কি হ'ব? Crores of hydrogen molecules, crores of bromine molecules will be there. Okay. Out of those crores of bromine molecules, say one bromine molecule dissociates like this. Okay, our bromine molecule kiman ase? Crores. Okay, crores. And he crores of bromine molecules. He je koti bromine molecule ase. Tar bhitorot say eta molecule enake dissociate hoise. Dissociate hoi ki hoise? Bromine free radical has been formed. Okay. Now free radical, this is highly reactive. Once this is formed, this will attack one hydrogen molecule. One bromine radical, it will attack one hydrogen molecule. Here red constant is K1, red constant is K2. Na, what is formed? HBr plus H. I repeat. So our bromine molecule kiman ase? Crores. Okay, tar bhitorot suppose eta molecule dissociate hoise. Eta molecule dissociate hoise. So tar pisot ki what is the next step? That bromine radical attacks one hydrogen molecule. Bromine radical attacks one hydrogen molecule to form HBr and hydrogen radical. Okay. Okay. This. Then what is the third step? This hydrogen radical, it is also highly reactive. So it will attack one bromine molecule. It will attack one bromine molecule. Okay. So again HBr, again Br radical. Now this radical again attacks one hydrogen molecule. Again this is formed. This will attack another bromine molecule. Again this is formed. Okay. This will attack again hydrogen molecule. This is formed. Okay, again this is formed, again this, again this, again this, again this. So this way the reaction continues. Okay, this way the reaction continues. Here this step is called the initiation step. Initiation step. Initiation step. Okay, now here you see this is the initiation step. Okay, initiation step. After this step, this is the reaction, and after this reaction, this is the reaction. Okay, after this reaction, this reaction. After this reaction, this reaction. Then this reaction, this reaction, this reaction, this reaction. So there is a chain of reactions. There is a chain of reactions, one after another. বুঝি পাইছা না কথাটো? প্ৰথমতে এইটো ৰিয়েকশ্যন হৈছে এটা ব্ৰোমিন মলিকিউল ডিছ'চিয়েট হৈছে আউট অফ ক্ৰোৰ্ছ অফ ব্ৰোমিন মলিকিউলছ। গতিকে ক্ৰোৰ্ছ অফ ব্ৰোমিন মলিকিউল আছে, তাৰপিছত এটা মলিকিউল ডিছ'চিয়েট হৈছে, ই এটা হাইড্ৰজেন মলিকিউলক এটেক কৰিছে, এইটো ফৰ্ম হৈছে, ই এটা ব্ৰোমিন মলিকিউলক এটেক কৰিছে, এইটো ফৰ্ম হৈছে, again this, again this, again this, again this. So reaction to proceed hoise, reaction to proceed hoise. Gotike ami ki dekha paisu, there is a chain of reactions one after another. Moi akoi bar koisu, first this reaction, next this, next this, then again this, again this, again this, again this. In this way the reaction proceeds. So there is a chain of reactions one after another. So this reaction is an example of chain reaction. Okay, our reaction to kune continue korise this and this. Okay, hydrogen radical and bromine radical, hydrogen radical and bromine radical. গতিকে এই দুটা বস্তুৱে ৰিয়েকশ্যনটো কেৰি কৰিছে, কণ্টিনিউ কৰিছে। গতিকে দিজ টু আৰ কল্ড চেইন কেৰিয়াৰ্ছ, চেইন কেৰিয়াৰ্ছ। অ'কে, চেইন কেৰিয়াৰ্ছ, চেইন কেৰিয়াৰ্ছ। হিয়াৰ হাইড্ৰজেন ৰেডিকেল এণ্ড ব্ৰোমিন ৰেডিকেল, দিজ আৰ দি চেইন কেৰিয়াৰ্ছ বিকজ দিজ টু আৰ continuing the reaction. Okay, এই দুটাৰ দ্বাৰা ৰিয়েকশ্যনটো কণ্টিনিউ হৈছে, সেইকাৰণে দিজ আৰ চেইন কেৰিয়াৰ্ছ। অ'কে, দিজ টু কেৰি অন দি ৰিয়েকশ্যন, চ' দিজ আৰ চেইন কেৰিয়াৰ্ছ। অ'কে, চ' এণ্ড এগেইন দিজ টু ষ্টেপছ আৰ কল্ড দি propagation step, propagation step, propagation step. This is the initiation step, or we may call chain initiation step, chain initiation step. These are the propagation steps or chain propagation steps. Okay, তাৰমানে এই দুটা ষ্টেপৰ দ্বাৰা ৰিয়েকশ্যনটো প্ৰপাগেট হৈছে, কণ্টিনিউ হৈছে। চ' দিজ আৰ দি প্ৰপাগেশ্যন ষ্টেপছ। তাৰপিছত কি হ'ব, then this will react with HBr, K4. So what we get? We get H2 and Br. Now here what happens? One chain carrier is destroyed. Okay, we have only one chain carrier now. Now reaction to car দ্বাৰা propagate হৈছে, এই দুটাৰ দ্বাৰা। Due to these two, the reaction propagates. Okay, if one is lost, the reaction will not propagate. এই দুটাৰ দ্বাৰাহে ৰিয়েকশ্যনটো প্ৰপাগেট হৈছে। গতিকে ইয়াৰ যদি এটাও নোহোৱা হয়, ৰিয়েকশ্যনটো প্ৰপাগেট কণ্টিনিউ নহ'ব, হৈছেনে? চ' this step is called the inhibition step, inhibition step, inhibition step. Okay, chain inhibition step or simply inhibition step. So what happens? Due to this reaction, speed of this reaction decreases. Speed of this reaction decreases because one chain carrier is lost. And finally, what happens? The remaining chain carrier is also lost. That means now there is no chain carrier. There is no chain carrier means the reaction will be stopped, terminated. So this is called the termination step. Termination step. So these are the 5 steps of this chain reaction. The chain reaction ki hobo? Chain reaction sarita step thakibo pare. In a chain reaction there may be 4 steps: initiation, propagation, inhibition, and termination. Okay. Once again, why we call this a chain reaction? Because within this reaction there is a chain of reactions. No? This reaction, this, then this, again this, again this, again this, again this. There is a chain of reactions. So we call it a chain reaction. Okay? We call it a chain reaction. Now, now for this reaction, we can use steady state approximation to find out expression for rate of the reaction. We can use steady state approximation to find out expression for rate of reaction. Okay. Now how to find expression for rate of reaction? Again from definition, rate will be equal to minus dH2 by dt equal to minus dBr by dt equal to half into dHBr by BR2 dt. BR2, okay, dt. So so let us take this as the rate of the reaction. Let us take this as the rate of the reaction, and let us take this as the rate of the reaction and find out expression for this from the mechanism. Okay. Now what we are going to do? We are going to write expression for this from the mechanism. Here you see we have HBr with these 2 reactions, second, third. We have HBr with these 2 reactions, second and third. So we will have 2 terms for dHBr dt. We will have 2 terms for dHBr dt. Okay. So let us write. Sorry. Okay. dHBr dt from mechanism. Okay. From mechanism dHBr dt. So what we get? So in these 2 reactions, HBr is formed. So we will have 2 terms. Both terms will be positive. Okay. So we will have K2 Br H2 K3 HBr2. Say this is the number. This is number 1. Okay, this is number 1. Now here you see these are the intermediates. Br radical, hydrogen radical. So these are the intermediates. Okay. So now what we have to do? We have to write d intermediate dt. So first let us write dH by dt. dH by dt. Okay. So you see hydrogen radical is there. Hydrogen radical is there, and there. With three reactions, hydrogen radical is present. So for dH dt, we will have 3 terms. Out of this term will be positive, and these 2 terms will be negative. Okay. So dH by dt. dH by dt. So this will be equal to K2 BrH2. This is positive. Then K3. This is HBr2. Then K4 HBr. Okay. Then there is another intermediate Br. So let us write that also. dBr dt. dBr dt. Okay. Now Br is present in all the reactions. In all the reactions, Br is present. Okay. So out of those, this term and this term will be positive. The other 3, okay, this term also. So there will be 3 positive terms and 2 negative terms. There will be 3 positive terms, 1, 2, 3. There will be 3 positive terms and there will be 2 negative terms. This one and this one. Okay. So let us write dBr dt equal to, so K1, this is Br2. Okay. Then minus, okay, K2 BrH2. Okay. Then this is negative. Then K3 HBr2. So this will be positive because here bromine radical is formed. Then minus plus K4 HBr. Then minus K5, and it will be Br square. Okay. Because there are 3 positive terms, 1, 2, 3. There are 3 positive terms. So here bromine radical is formed, and here bromine radical is destroyed. So these are negative terms. Okay. Now steady state approximation, d intermediate dt equal to 0. So this is a 2, this is 3. Okay. So from 2 what we get? From 2 we get that. Let me write here. Okay. Let me write here. from 2 we get d intermediate dt equal to 0. So this is equal to k2 br h2 minus k3 h br2 minus k4 h hbr. Okay, so this is a 4, and again this is equal to 0. Okay, so k1 br2 minus k2 br h2 plus k3 h br2 plus k4 h hbr minus k5 br square. Okay, this is step 5. Now we are getting two equations 4 and 5. We are getting two equations 4 and 5. Okay, now what we have to find out? We have to find out expressions for this and this. We have to find expressions for this and this. Okay, so we can do one thing. If we do this, say 4 plus 5, if we do this, let us see what we get. This is 0. Okay, 4 plus 5, so here this is positive, and this is negative, cancel. Okay, then this is negative, this is positive, cancel. Okay, then this is negative, this is positive, cancel. So these terms will cancel out, hence what we get? This is k1 br2 minus k5 br square. Okay, br square. Hence br, that will be equal to br will be equal to k1 br k5 br square, that is equal to k1 br2. Okay, so br equal to k1 k5 br square whole to the power half. Okay, whole to the power half. So we are getting the value. So this is the number 6. So we are getting the value of br. Okay, now we are getting the value of br. So we have to find out the value of H radical, hydrogen radical. So what we do? We put this value in 2 into 4. We put this value in 4. Okay, and let us see. So let us put this value in 4 and see. Okay, let me write it like this. K2 br h2. Okay, K2 br h2 equal to K3 br2 plus K4 hbr, hold this into H. Okay, hold this into H, or K2, K1, K5 whole to the power half BR2 whole to the power half H2 equal to K3 BR2 K4 HBr H. Okay, hence what is H? This is equal to K2, K1, K5 whole to the power half BR2 whole to the power half H2. Okay, this divided by K3 BR2 K4 HBr. Okay, HBr. So we are getting this. So we are getting the values of BR and H. Okay. Now what we do? We put the values of BR and H. We put the values of BR and H in one. We put these values of BR and H in 1. Okay. So this is a 7. Hence from 1 DHBr dt equal DHBr dt equal to K2 into BR. What is BR? K1, K5 whole to the power half BR2 whole to the power half and H2. Okay, so BR, for BR I am writing this, then we have H2. Okay, then we have H2. Then K3 H. For H we have to write this K2 K1 K5 whole to the power half BR2 whole to the power half H2 K3 BR2 K4 HBr and BR2. Okay, so we have got this. Then we can simplify this. Let us simplify this. So I have committed one mistake. You see, say HBr. Here we have HBr. Then here also we have HBr. So this will be K4 minus HBr. See, therefore it is. So I have committed mistake. K4 HBr. Okay, this is 1. So minus K4 I can do one thing. Okay, I can nothing. Okay, K4 into H equal to K2 K1 K5 whole to the power half BR2 whole to the power half H2 then we have K3 BR2 K4 HBr okay into HBr or I can write like this or say from 1 I can write like this dHBr dt equal to K2 BR H2 plus K3 BR2 minus K4 HBr hold this into H. Okay, I can write this like this also. Then the calculation will be a bit simplified. Okay, calculation will be a bit simplified. Otherwise, you can do like this also, no problem at all. Okay, so this is equal to from here also I can write. Let us take whatever we can take common. Okay, from this I can do like this or I can do like this. Well, let me consider this. Let us take common, whatever we can take common. So from this, what we get? dHBr dt that is equal to I can take I think I can take this common. Okay, I can take this thing common, K1 K2 K1 K5 and this thing common, K2 K1 K5 this thing. Okay, I can take this thing common, so K2 K1 K5 whole to the power half H2 BR2 common, BR2 whole to the power half. I can take this common, so what will be there inside? Then what will be there? K3 by K3 BR2 plus K4 HBr. Okay, then minus K4 minus K4 into 1 by okay, this is K2 BR2 this is here we will have HBr, K3 BR2 K4 HBr. Okay, K4 HBr. So I can take this common. So this is equal to K2 K1 K5 whole to the power half H2 Br2 whole to the power half. So what I can do, I can simplify this. K3 Br2 K4 HBr. I can simplify this. If I simplify this, what I get? I get K3 Br K3 K3 Br2 minus K4 HBr. I get this K4 HBr. This calculation, my calculation, is it correct? What I am doing? There is 1 plus, no? There is 1 plus. What I am doing? This is plus 1. Okay, this is plus 1. So plus 1. What I am doing? Okay, see, I have taken this common. So 1 will be there. Then this term, then this term. Okay, 1 will be there. So plus 1 will be there. So this is equal to K1 K2. This is K2 K1 K5 whole to the power half H2 Br2 whole to the power half. Then you see K3 Br2 plus K4 HBr. K3 Br2 minus K4 HBr plus K3 Br2 plus K4 HBr. Okay, K4 HBr. So K4 HBr cancels. So we have K2 K1 K5 whole to the power half H2 Br2 whole to the power half into K3 Br2 plus K4 HBr. Here 2 K3 Br2. Okay, 2 K3 Br2. So we are getting this. So we are getting this. Then what I can do is that I can do here, I can divide by BR2. I can divide by BR2. Okay, I can divide by BR2, so that what we get d HBr dt equal to K2 K1 K5 whole to the power half H2 BR2 whole to the power half into 2K3 dividing by BR2. So okay, if I divide by K3 BR2, we are dividing by K3 BR2. Okay, K3 BR2, so this will be 2 into 1 plus K4 by K3 HBr by BR2. Okay, or we can write half d HBr dt. This is equal to again K2 K1 K5 whole to the power half H2 BR2 whole to the power half 1 plus K4 K3 HBr by BR2. Now this is the and this is nothing but rate of the reaction. We have already seen. So this is the expression for the rate law according to steady state approximation method. Okay, this is the rate law. Okay, so so we have to deduce like this. So we have done we have used steady state approximation method to find out the rate law, rate law of this reaction, of this chain reaction. Okay, now there may be two types of chain reactions. Okay, there may be two types of chain reactions. Two types of chain reactions. One is called branching chain reaction. The other is non-branching chain reaction. There are two types of chain reactions: branching chain reaction and non-branching chain reaction. So what is the difference between the two? Now in non-branching chain reaction, let me give the example. So these are the two propagation steps. This is chain reaction. These are the two propagation steps. Now here you see, in this propagation step, one chain carrier is destroyed and only one chain carrier is formed. One chain carrier is destroyed and only one chain carrier is formed. Again here, this is another propagation step. Here also what happens? One chain carrier is destroyed and only one chain carrier is formed. Now this type of chain reaction is called non-branching chain reaction. In non-branching chain reaction, one chain carrier is destroyed and only one chain carrier is formed in the propagation step. One chain carrier is destroyed and only one chain carrier is formed in the propagation step. That is non-branching chain reaction. Non-branching chain reaction. One chain carrier is destroyed and only one chain carrier is formed in the propagation step. Okay. Now if one chain carrier is destroyed and more than one chain carrier is formed, then this will be branching chain reaction. One chain carrier is destroyed and more than one chain carrier is formed. That will be branching chain reaction. Okay. So these are the two types of chain reactions. Okay. So let us stop here today. Next time we will discuss in general about chain reaction. Okay. So you practice these things. This at first these seem to be difficult, but actually not difficult. You will find it easy. So any problem you can ask me. Thank you.